All right, everybody, we're going to get kicked off here. My name is Matt. I'm with One Technology. Also on is Nick Strader, who runs our U.S. public sector business, and Jeff Benton, who's our VP of Engineering. Wanted to thank everybody for joining. Today, we're going to be talking about HPC Backup and Archive with Igneous. On the call, we've got Eric Hanna, who is the account manager for the high performance computing space, amongst other things. Presenting today will be Adam Marco and Christian Smith, who are going to talk about Igneous in HPC environments, how their tools are used, what they're used for, and value that organizations are getting from the tools. So with that said, I'm going to hand it over to Adam Marco, who's going to start his presentation.
Thanks, Matt. Adam Marco here, as Matt introduced me, and we're from Igneous, and we'll be talking about backup at the scale of HPC. I'm the scientific solutions lead at Igneous, and Christian Smith, who will also be presenting, is our VP of product.
Yes, we need to flip the presentation here a second.
Got it. I have it on. Matt, you're going to have to stop screen sharing so I can. Yeah, thanks. Okay. How's that look? You see pictures of Christian and I?
Yes, that's good.
Great.
So Adam, go ahead and introduce yourself, just now that you've got your bio up, and then I'll introduce myself and kick this off, okay?
Great. I'm Igneous' scientific solutions lead. I have about 10 years of experience supporting research initiatives at a variety of different organizations. I have experience in HPC, drug discovery, molecular diagnostics, and most recently, research IT consulting. I had done the research IT consulting for about 4 years, and one of the consistent themes across tens of organizations was storage issues, and in particular, data management. There were constantly issues around understanding your data, seeing your data, backing up your data. Scientists were worried that their data wasn't protected. IT was confused as to how to do this. I continuously saw these issues, and I was also at the time aware of what Igneous was doing. Having seen that and having seen the issues, I joined them because I was excited to know what they could do to really help the HPC and research community. So here at Igneous, I help with our HPC customers, our life science customers, and really figure out how Igneous can help meet their needs, as well as translate their needs to product development efforts at Igneous.
Hey, I'm Christian Smith. I'm the VP of product here. So I've been here pretty much since the beginning. My background, just to give you a little bit of history, is I've been at places like Isilon, NetApp, Silicon Graphics, pretty much have dealt with file workflows my whole life. The big thing, though, that I wanted to just talk about Igneous is our history and lineage is all from the places mentioned. And so when we talk about file-based workflows, we have a lot of history in this and a lot of experience in this. And really the goal for us was not to go build yet another file system out in the marketplace. It was really to tackle the harder problems around data management. So that was what we set out to go do. And just to kind of frame that, the reason why we started tackling that space was because there was all this data and all these different, segments and verticals out there that predominantly lived in the data center, and it resided on enterprise NAS. And it was this challenge of volume and velocity that we saw that said, hey, what the world needs is not yet another one of these. What the world needs is a little bit better way to start managing this data at scale. And when we talk about scale, the big things that we talk about are the things that you try to do with data. It is the visualization of data. How do I know what I have? It is protecting data. Like, how do I actually do this at scale? How do I do this across platforms? How do I do this at the right economics? How do I move data around? Like, when you start talking about workflows, there's just a general movement of data around. And for anybody that's really dealt with file for a long time, you know that like traditional tools don't work. There's a lot of vendor specific things and silos. There's these great things like cloud that exist out there that maybe have burstability, but how do I actually leverage it in a way that reduces data center footprint and space? And we understand all the kind of challenges of files with billions of files and petabytes of data, and the different tiers that it could live on, and that there's this sort of natural mix of large and small data sets all mixed together that you've got to just handle, which is very different than dealing with structured data. So why don't you talk about HPC, Adam?
Sure, definitely. And just confirming that everyone can see the entire presentation. Is that working?
I can see it.
Okay. Yeah, so as I mentioned before, I was a consultant for a while and almost exclusively in HPC type environments, dealing with scientific and life science computing. And part of the reason these organizations hired consultants is because they were obviously having some issues. And so what I found with respect to backup and archive at these places is backup was rarely deployed. And there are a lot of reasons for that. There wasn't always a budget for backup. Paying for replication from a vendor can be very expensive. There was lots of pressure to do other things. The IT staff is really there to support researchers. They're not there to necessarily worry about backup. So in addition to the time constraints as well as data center constraints, backup just wasn't that common. In addition, archive is extremely complicated. Stubbing is probably the most common thing that's implemented, but it comes at a high staff and technical overhead. And any reliance on tape requires a large physical footprint. And finally, cloud's rarely used. And there's a lot of reasons for that as well. Cloud methods don't necessarily support, traditional methods don't necessarily support the cloud, and leveraging the cloud can be expensive depending on how it's configured. So that's where a lot of places are, but where you need to be is with a scalable, simple, cloud native and flexible as a service solution. So something where you can hit your SLAs and you don't have to worry about it. Something that's easy to deploy without lots of hardware or data center visits or dependencies. Something that can take advantage of the cloud or your local hardware as needed. And as a service, so you don't have to babysit your infrastructure. Backup should not be keeping you up at night. It should be something you can set and forget and rely on. As part of the backup, Igneous provides a product called Data Protect. So Data Protect is a modern network attached storage backup solution. We install on a VM and we can use as a source any NFS network attached storage or SMB. We do have API integration with several vendors, but again, we could work with any NFS gateway. And our Data Protect product manages your backups and can write to any of the major cloud providers in any tier or any private S3 or any private NFS for your destination. And Igneous was designed from the beginning to be extremely scalable, handle trillions of files and hundreds of petabytes of data. It was also designed to help you manage cost and be cloud ready for organizations that want to move that direction or already had a cloud footprint. And we are available on the AWS and Azure marketplace. We were designed for true scale-out data protection. So any scale. Our customers in general start at 100 terabytes, but most of them are much more than that. So we were designed for hundreds of terabytes and millions of files, all the way to 100 petabytes and trillions of files. And this is all through a single interface. Many organizations, especially large HPC installations, will have multiple NAS systems of varying size and type and file footprint. We're designed so that you can view all of those through one interface. And we'll work with any, go ahead.
Yeah, I was just going to say, like, this is a good example where we have a case study on our website with Quantum Spatial. They do a lot of like planes flying overhead, and they have a lot of satellite imagery that they download and process. It looks like most HPC workloads where there's a capture from plane, a bunch of processing, and then a workflow automation to go push it off into the cloud. They're an example of a site that moves petabytes of data around on a weekly basis. They also have multiple sites. And so in their 7 sites, their big value is that they can see this through a single pane of glass and manage all locations, all data movement through a single pane of glass. So why don't you talk a little bit more about the capabilities then Adam?
Sure. So we were designed for HPC level performance, and I'll talk about our specific technologies a little later. But in summary, we don't want to overwhelm your application. HPC is, the performance is critical, if nothing else. So we have user space clients and we minimize IOPS. We have a custom data structure that we wrote for our file index. We're not based on a Postgres database or any other type of relational database. We are latency aware, as well as having dynamic throttling. What that means is we can monitor latency on primary storage so we don't interfere with user workloads. This plot here shows how we adapt dynamically to user operations. So as those scale up, we scale down. And this is to eliminate impacts to other workloads. You certainly don't want backup slowing down HPC and delaying the time to results.
So, and this is partly what makes cloud usable for us. So Adam just mentioned there's 3 components that we talk about of our infinite index, our adaptive scan, and our IntelliMove, which we'll talk about later, of having the foundational components of what we do to make sure it scales at the scale of the enterprise, or the scale of the environment, or the scale of the organization. But when we started down this path, we said, hey, cloud is going to be something that is really predominant in the future. And one of those places for backup is, how do I replace what I'm doing today, or how do I implement something that leverages the cloud and do it with the right economics? When you start talking about Glacier Deep Archive, you're talking $12 per terabyte per year. When you talk about Azure Archive Blob Store, you're saying the same thing, and also with Google, but they have their characteristics that can really catch you if you're not conscious of the ways that they charge. And so we've been in this world where we have optimized for the cloud first. It still works going to private S3 and private NFS in the same way, but it is a parallel ingest, a multi-threaded ingest. And then we do a lot of work to make data efficient going into the cloud and being expired from the cloud. And so what does that mean? Well, we take a bunch of small files and we aggregate them together. We take big files and we create multiple chunks, but we create the appropriate size chunk so that when you're writing that data into the cloud, if you were putting 1 billion files in, it'd be around $500. If you did that in native format, you put 1 billion files in, the transaction cost of 1 billion files into Azure Archive Blob Store would be somewhere around $50,000. So these are the things that you have to be really aware of when you're starting to leverage the cloud to make the economics work. And of course, we do all the compression and efficiency associated with putting data in the cloud so that you're trying to get it in the most optimal footprint possible. The other thing we do is we've decoupled expiration from what we'll call compaction or reclamation of data, which means that if you have a retention that you want to set on data, whether it's 30, 60, 90, 180, 5 years, 6 months, whatever it is that we don't actually just go immediately expire that data from the cloud and reclaim that space, because that can get costly also. What we do is we expire data out of the index, and so it's no longer recoverable, and then we run a compaction algorithm on the back end that says when it is cheaper to go reclaim that data and compact that data based on rehydrating it, reading it out, and putting it back in, we will do that, and we'll do it when it's cheaper to go reclaim it than it is to store it in perpetuity. So as a result of that, when we go and meet with folks, the economics that we typically align are, how do you evaluate what you're spending today? And how do you work on a TCO that makes sense? And the big part of this is it's pretty customized to everybody that does this, but there's a lot of different components into backup that we don't always think about. There's the easy one, which is if you're on tape and the tape costs, but it's also the amount of data that you're moving. It is the refresh cycles that you go through. It is the efficiency of operations associated with it. When you go to disk, it's probably the Cadillac of backup when you're going disk to disk and using vendor-specific replication. That's great for DR, but you're probably overloading yourself for backup. And then when you go to cloud, it's those things like cost around transactions and cost around storage. So we have this great ability to go dissect all those costs for you and provide you with the TCO before you get started, before you try it out, just to say, hey, like, is this going to make sense for you? So backup is one thing. The other thing is that, we've talked about the 3 challenges people have around visibility and protection. The thing is in order to go manage any large scale data environment, you got to know what you have first. And this was something we released about a year ago called Data Discover. And so Data Discover is about giving you visibility into your environment so that you can start to think about what are ways that I can optimize my environment better. And I like this little infographic because it seems to play out when I talk to a bunch of folks, which is, what is the story around archiving? Well, the story around archiving is, hey, we're full, you ring the bell, you tell everybody to go clean up a bunch of stuff, a bunch of people run around, delete data, move it off into their disk drives on their desk, they go put it on thumb drives, they try to shove it in Dropbox, all these different things. And so the biggest challenges that we've seen is, one is that data is not readily available for reuse in an easy manner. And that too, the process yields little results to go free up space. And so you really end up in a world where you ring the bell and all of a sudden everybody runs and does stuff and you still end up buying a bunch more storage later. So this was part of the reason around Data Discover, which was if we can make it really simple and easy for you to deploy a VM, you point it at all your file environments, we'll go give you a heat map dashboard into your environment. It really is as simple as that. It's not a project. It's not deploying a bunch of hardware. It is a VM that does all this scanning and aggregation of all metadata that applies the same kind of core components around adaptive scan and the infinite index to provide you with that visibility. The result of that is you can now start to take more surgical action to free up NAS. So this is the dashboard that we talk about is you can now see all your data that's aged. And what we age by is by directory or project. And so you can go in, you can see in a given directory, how much data is there, how many files are there, and you can see the age, and you can start to toggle the age on these directories to start looking for specific chunks or segments or projects of data. And we don't care whether it is, petabytes, if it's hundreds of petabytes, whether it's hundreds of terabytes, it is the same view, it is the same refresh cycle. This data, goes out, it scans fast, and you get your results on a weekly basis. And it does it all with disrupting what's going on behind the scenes. For most organizations, we scan all this data in under a day for them. And so it's very fast and light way to go use and deploy. Once you're at that space, you can go do one-click action to go archive your data. And so now you can use those economics of the cloud to go archive your data off, or you can use on-premises object or NFS targets to go archive your data. The biggest thing with archive is you probably weren't using it, probably nobody was touching it. So you're in an environment where archiving it off without stubbing is probably beneficial because you're going to keep your file counts lower and you're going to keep your operations of your primary NAS in better shape. But you're also going to gain the benefit of being able to search for that data once it's been archived. So you can go find it again on multiple dimensions to go search for that data. And you can restore exactly what you want. Do you want the whole thing or do you want just portions of it out? But it'll bring it back and restore it to wherever you want it to go.
Thanks, Christian. So we talked about the problems that people are facing and some of the things that Igneous does. So why would you choose us? We are really designed for HPC scale. We weren't a software product that was designed to handle small Windows file backups and then decided we were going to do HPC or decided we could handle multiple NAS and billions of files. We were designed from the beginning to scale to your capacity. As Christian said, whether it's a few hundred terabytes or a few hundred petabytes. And at the core are 3 technologies: adaptive scan, IntelliMove, and infinite index. These products uniformly scale in performance and capacity. They interface with your primary storage, and they provide a search interface so you can see what products you're backing up or what files you're backing up. Adaptive scan is the first core technology I'll talk about. And this is how we scan your file system metadata. This uses 75% fewer IOPS than Linux, and it can move data at line speed. Our numbers are around 400,000 files per second, and I'll talk about a customer example at the end, which is faster than any other product that I'm aware of. We have custom-built clients to attach to your NFS or SMB storage systems. And we connect directly to those shares. We're not mounting them. We're not running an agent on your servers. And we have multiple threads that dynamically allocate work, and those threads load balance as well. So if one thread completes, it can take work from another thread. There's also latency monitoring that scales up and down dynamically, which we talked about. We don't want to affect your user workloads. And there's no single task bottleneck.
And so, Adam, just I'm going back to that. Like, here was the reason why we did this. It was really important to go out and say, hey, we got to go scan through lots of data. And in order to go scan through lots of data, I can't mount file systems and go through a kernel. That is really, one, requires a lot of IOPS and work. It also requires a lot of CPU to go do it on whatever you're deploying. This is why we can deploy through VMs, is because we wrote our own, call it NFS Lite or SMB Lite connection. And then the other thing is what bogs people down, you know, if you're thinking about this from an rsync perspective, if it's doing an rsync and just doing a tree walk, is the imbalance associated with file systems. A lot of those technologies are hard bound to a directory path. And so even in the best ways where you try to distribute that movement of rsync and run multiple at a time, you're still going to be in that mode where the longest running or the deepest tree is going to take the longest amount of time. And so by having this dynamic reallocation, we can just keep churning through file systems at a speed so that, you know, it doesn't matter whether you're in a deep one or a shallow one, it all finishes predictably across all your environment without you having to actually think about how it gets distributed across that environment. So you want to talk about the next one, Adam?
Sure. IntelliMove. So IntelliMove is what actually moves the files. So this is highly parallelized. We compress the files. Again, it's latency aware and optimized for massive unstructured data. There's a native API for certain NAS and cloud vendors. Well, native API for all the major cloud vendors. But from your network attached storage, we can certainly work with any generic NFS or SMB if your API is not supported by us. And again, it's very similar technology background, custom-built clients, multiple threads, dynamically allocate work. We are prepared to handle mixed files of different sizes and amounts. We're not something that fails on small files or fails on large files. We were designed to handle any kind of mix. And the same latency monitoring and no system bottlenecks, as we mentioned before.
Yeah, and so on this one, if you think about the scan part of it is when you go out and you find data and you want to move it around, you got to go then find data, you want to then go move it around. So this is the next set of thread pools that do the work for actually moving data. And again, back to that, I don't want to create a mountable through a kernel data mover, but the real goal here is to pipeline the data movement activity as much as possible. And so when you're talking about, I have to read data, I have to aggregate data, I have to compress data, and then I have to push that data off. And I've got big files and small files. And so ultimately what it becomes is this pipeline activity and keeping a lot of data in movement at all times. And whether you're talking about small files or big files, you know, we've done it all. We have environments that are, you know, several petabytes, but are 100 billion files. We have environments that are several petabytes and there are hundreds of millions of files. And so you've got to be aware of how you can handle each one of those types of environments dynamically without having to do a bunch of customized tuning. The result of that is we just keep data moving. Like you keep it up in the air, you keep it in pipeline from coming off the system to pushing it through. And then the biggest thing of this is that when you're moving data is probably the most impactful to, you know, impacting latency on source systems. And so we're always monitoring that latency of that source system so that when applications are running, because when you're moving, you know, a couple hundred terabytes of data, it's going to take a while. It's not going to all happen, you know, shortly. So chances are you're bleeding into the hours when people are actually doing work. You know, we're going to scale back the number of threads that we're using to do work as that latency pops up. And then in those kind of off cycles, we're going to go scale back up again. And so you don't have to think about, you know, do I have to tune this daily, hourly, minute, etc. We just take care of that for you.
Finally, our third core technology is the infinite index. So I had mentioned this earlier, but this is our global scalable metadata index. It is our own custom data structure. As I mentioned, you don't have to install a relational database, and we're not backed by something like that, because those types of technologies fall apart at the scale of HPC. You can throw hardware at them for a while and you'll get some level of performance, but once you get to the level that most of your organizations are at, they simply won't perform at the rate that your data is being generated. And our index is decoupled from compute. We don't burn a ton of compute cycles as we're writing this index. It supports billions of entries and high insertion and query rates. And we can support multi-dimensional queries as well.
So the index to us was the critical part of this, which is when you start talking about, backup and archiving data, the difference between just replication and backup and archive is the index that goes with it, so that you can keep track of versions and histories, and you can search through it, and you can create views that are like the data discover view that we show off that index. It turns out indexes are historically driven off of regular databases, and they don't have the scale to handle hundreds of billions to trillions of requests. And so you've got to do a lot to both minimize the footprint of your index. Like, I don't want to deploy a whole bunch of storage and servers to go store my index. And you got to do it in a way that has the queries you want to ask already predefined in it. And so, our index is the counter snapshot to finding change in file system. Our index is the view that you see from data discover. Our index is the search over ad hoc queries to go find data that you want to restore. And it's really built around this concept of something you have to build yourself to do it, to maximize the efficiency at scale. And so that is why we built the index the way we did. And it's really those three pieces of the move capabilities, the scan capabilities, the index capabilities that work together to offer our archive, our data discover, our data protect in the ways that you want to use it in your environment.
Thanks, Christian. So a short customer example about real-world performance. This was a customer HPC environment. They have petabytes of engineering data, and total capacity was about 8 petabytes with 19 billion files. We were able to scan this in 14 hours, which works out to about 378,000 files per second. And just a little bit of details about the systems. That was Isilon and Pure FlashBlade. It was a heterogeneous mix. So we're really designed to be deployed in these environments and just get up and running and get you answers very quickly. Go ahead.
To say, so, we shoot for, on our data discover stuff, to have you a fresh view of your data every week and get it done, before the Monday hour rolls around. The good news is we hit that quite a bit, and we have really cool stats about what does it look like in an average environment. Like, an average environment has 50% of its data hasn't been touched in over a year, if not 2. An average environment is 6 petabytes with 3 billion files in it. An average environment, can get up and running and get scanning and produce results in as little as a few minutes once this starts. And so really it's that visibility portion of it, but it's also plays to the, when I'm going through and I'm scanning for change rate, these numbers hold up. These are the type of numbers that you would start to see when you're doing data protect, when you're doing your level 0 incremental forever type of model. So we really like to pride ourselves on being fast and being simple and being easy to go use and deploy, and not require a lot of infrastructure deployment, management, or oversight.
Thanks. And that concludes our presentation. We're here for questions, and we can always schedule a remote live demo with you at a time that's convenient.
Thank you, Adam. The Q&A tab at the bottom is open if anyone has any questions. Also, don't hesitate to email me, Matt Brown, or Eric Hanna, or Christian, or Adam. So we'll make everyone's contact information available to everyone who participated. And if we don't have any questions here now, we'll wrap up.
Oh, hey, there is a question that came in. One was about how do you integrate with APIs?
Perfect. Christian, you want to take that one?
Sure. So the big thing about the API integration is there are certain tasks that you need to do, like on NAS devices, like an Isilon Cumulo, Pure FlashBlade, and NetApp, which is I want to take a snapshot, I want to traverse the snapshot, I want to have permissions set so that I can go get the data. And so we do a lot of work to go make that a simple, effortless experience. One, we import the entire namespace regardless of what type of platform it is, and then you set policies on that namespace. The APIs just mean that you don't have to go touch those NAS devices to go do the things that you would need to do to go back up those systems or archive those systems. That's all handled under the background of that, and it's a pretty cool experience to see just how easy it is to get up and get going. Another one was, can you write directly to cloud tiers or do you stage data? So we write directly to like Azure Archive Blob Store. We write directly to Glacier. We don't have to stage it in sort of the hot tiers and then commit it down. And a lot of that is because we don't use that data as the counter index. So we can go directly into those tiers. And by the way, the data lives in your account, your Google, your Azure, your AWS account. And so we don't need to access that data to go do the counter snapshot. That is the infinite index that's doing that work, which means that you're not going through that land and hot tier, paying for a period of time, and then committing it. There's some real cost associated with doing that. There's another one, which is, do you see Igneous fitting into the service model to departments? Like, how do you start to delegate out data management capabilities to different departments and stuff? You know, there's a lot of work that we do from an API perspective to go provide, whether it's reporting or whether that's visibility into what's going on. And that story is going to continue to get richer and richer as we start to delegate data management to the people who care. So give them the ability to see the data that's theirs, to take action on the data that's theirs, and really becoming more of a service-oriented organization where, you know, you as an infrastructure person or research IT or whoever can just set up and set permissions and delegate it off to the people who care about their data. Anything else? Quiet group.
All right. Well, everyone, thank you for joining us. Thanks for participating. We hope this was informative. And if anybody has any questions, as I mentioned before, don't hesitate. We'll make sure everyone, the Igneous and the OneTech team's information is available to everybody.
Thank you all.
Thanks, everybody.
Thank you, Matt. Thank you, guys.
Thanks,
All right.
everyone.